In the last video, we talked about factoring quadratic expressions as a way to solve limit problems that we couldn't solve otherwise. So that went back to our Algebra 1 knowledge. What I am going to do today is to go back to something that maybe technically is a word that you were supposed to have learned in Algebra 2. You may not have learned it specifically, but we'll talk about it right now. All right. Once again, we're going to start with this identity that we talked about in the last video, that if you take a minus b and multiply it to a plus b, you're going to get a squared minus b squared is your answer. So let's see how we can use this to solve a problem like this. We'll talk about the limit as x approaches 4 of x minus 4 over the square root of x minus 2. So once again, if we plugged 4 in for x in this equation, we would get 0 over 0. So that's our indeterminate form, which means that we need to find some other trick in order to calculate this limit. And so what we're going to do is it's a term called, we're going to rationalize the denominator. And what rationalize means is it means get rid of this square root symbol. So we want to make this into a rational expression in the denominator. And so what we're going to do to make this happen is we're going to use this identity right up here. So we're going to take the square root of x minus 2, and we're going to multiply the numerator and denominator of this expression by the square root of x plus 2. We just took that binomial and we switch the sign of it. The fancy mathematical term for that is the conjugate. And when we do that, once again, we have the limit as x approaches 4. In the numerator, we've got x minus 4 times the square root of x plus 2. And in the denominator, we have the square root of x minus 2 times the square root of x plus 2. And when we plug this into our expression here, the numerator is going to be the same. X plus 2 over, in this case, my a is the square root of x, so this becomes the square root of x squared, and our b is 2. So this is going to be minus 2 squared. All right, so this is a little bit simpler. What can we do to simplify the square root of x squared? Well, we know that x is a positive number because it's a number that's close to 4. So these two operations are inverses of each other. So that's the limit as x approaches 4 of, once again, x minus 4 times the square root of x plus 2. The square root of x squared is equal to x, and 2 squared is equal to 4. And now that we've got this situation, we can do the same thing that we did in the factoring video. We've got a term of x minus 4 in the numerator and denominator, so we can cancel those out. We can do that because x is not equal to 4, because x is a number that's near 4. So this is the limit as x approaches 4 of the square root of x plus 2. And now we're at a point where we can use our rule 1, just substitute 4 in for x, and that's the square root of 4 plus 2. Square root of 4 is 2, and 2 plus 2 is 4 for our answer. All right, so you will see problems in your IXL where you need to rationalize the denominator, which means to do this trick to it in order to get to this point where you can cancel out an x minus 4 from the numerator and denominator. Sometimes you're going to be asked to rationalize the numerator. You'll have a square root expression in the numerator. And once again, you're going to multiply the numerator and denominator by the conjugate of that expression, which is just your radical expression with the sign flipped. And then you're going to be able to use this expression and then just do a little bit of algebra and you get straight for your answer. So that's the notion of how you use rationalizing in order to solve a problem.